Right, hello and welcome. And in this video, we will be looking at how to port a customized script or an exploit into Metasploit Framework. So I'm using the Von app, the vulnerable application exploit, which you probably should have a custom exploit for. So I've got mine here, the Python script, the shell code. I've got my buffer, which has been sent within the exploit using a Python socket connection to the vulnerable Windows 7 lab machine running the application. So I'm just going to test my exploits to be sure it's working fine before. So right click, run as admin. Okay, so I've got that running. And over here, I could have my reverse shell. And there we go, exploit works. Right, so how do we then write a customized exploit for Metasploit? So how can we port this vulnerable application Python script into Metasploit? So we'll be able to automate the exploit. So in order to do this, you have to go on to Immunity Debugger, right click and run as admin. The Immunity window opens up. And if you go onto the CPU window, underneath here, you just type in !, Mona skeleton, and click on enter. So a window pops up that says select MSF exploit skeleton to build, because the exploit is using TCP socket. So I'm going to go for network line TCP, click on OK, ask for the remote port number, and that will be 9999. Click on OK. Now Mona has written out a file called msfskeleton.ruby. So go into C, go to the program files, Immunity Inc. folder, Immunity Debugger, and you should have a file called msfskeleton. So as you know, Metasploit is written in Ruby, hence the reason we've got a Ruby file, an RB file. So you have to open this up with, a notepad. And here you can see the skeleton script. So you got require MSF core, you got a class, which is a Metasploit 3 remote, and defines it as a remote TCP exploit. Then you have a definition of creating within the class. You have an object being initialized, and you have all the parameters necessary for you to actually port or customize this template. So I've already done this. So I just moved over this file over to my Kali Linux machine, and I've got it here. So have a look at it here. So that is the script. Okay. So all the parameters we need is within our custom Python exploit. So I'm just going to copy out the exploit, copy it into a notepad. Right. Now we have to start editing the Metasploit exploit. Okay. So the first thing we have to do is to make some changes. So here it says insert name of exploit. So I'll call this custom vulnerable server stack overflow exploit. So a quick description of what sort of information you might want to put into here. So information about the vulnerability. So so I could say this exploit, this module exploits a stack buffer overflow in a custom vulnerable server. All right. All right. So the license is MSF, so we'll leave that as is. We could include an author, so we can include a name of the person who discovers this vulnerability. So I'm just going to put in my name there, even though I didn't, but I'm writing this exploit. Okay. So what else? So you might want to put in, customized references. I don't think all of this is quite important anyway, so we'll move on. So the platform here is Windows, so we'll leave it as is. And here we have to put in the bad characters. And if you remember in your customized exploit, you probably found the bad characters you need. So the bad character here has to be, I think it was X00 was the only bad character I identified when I did this. So disable NOPs. I'll leave out. So we're not disabling NOPs because we've got NOPs in our exploits. So if we go into our exploit, you can see we've got about 16 NOPs. So I'm going to leave that out, write that as false. Okay, so we might want to fill in the target. So I'm just going to put this as Windows Universal. So this works on all Windows versions. Okay, now the return address. So from our exploit here, the return address is 625011AF. So we can go in here and put that in. So X625011AF, which is the return address. The offset is 2003, which is the number that actually fills in the buffer. So like we have in our exploit here, which is 2003, and that's why I've got 2003 here. Anything else? So privilege, we leave that as is. Correct date and time, and the exclosure date target equals 0. So this might be if you have multiple versions of Windows, then you might want to set the different targets to 1, 2, 3, depending on probably the operating system or the version of Windows. So you can see here by default, the template created the remote port, which is 9999, which looks fine. So I think everything looks fine here. Now, this is where we have to define the exploit. So on how this exploit should work. So we've got the connect, and then we've got this part of the exploit which says buffer pattern create. And here you could have to then customize the exploit based on the values you have in your buffer here, and set up how Ruby is going to connect, which is similar to Python, on how it's going to connect to the host and send the exploit. So that's the part that really gets tricky, because if you don't get this right, then the exploit probably wouldn't work. So here, I'm just going to get rid of this. I'll call these exploit equals, so we can copy the first line here, which is the Tron. So we copy this. Okay, so this is the first part of the buffer. On the next line, we have exploit. All right, and then we have plus equals, which means we've already defined this variable called exploit, and then we append in whatever is going to go here to the exploit variable which we've initially created. So here I'm going to define the target. So the user has to define the target, and so remember here. So what needs to go here? If you remember, we've got the Tron, the number of characters with 200. So next thing we're going to write the return address. So after this, the next thing in our exploit is the return address. So in order to do this, you say target.ret, which is return, because if we go back here where we have the return address, you can see this is so you're referencing, you're making a call to targets, which is a variable here, and you're saying within targets is where we have this RET return. So we define that variable here. So to call that whatever value we've got into tar.ret will be sent here. Okay. .park v and then plus. So we're making this, we're referencing the return address. So we create number of nops. So make underscore nops, and we had 16 nops, wasn't it? So we put in 16, which is the number of nops we have in our exploit. So make nops will allow Ruby generate 16 nops, and then plus by default use a reference to use a payload, a customized payload. So the default payload will be chosen, and that will be encoded. Right. So here you could customize this. So if you want something to go in here, so I could say print status sending exploit. So we have some information when the exploit is sent, and here I just replace this because I changed this parameter to exploit. So I'm going to call this so this is working as the same way the exploit here is working, sending the buffer, and that's exactly what this is doing. So if you look at this exploit, it's quite ready, and by default when you run this, because we haven't set a remote host, if you have a look at our exploit, this initially has the host address within the exploit, but when you run this in Metasploit will prompt us automatically to supply the remote host, which is fine. So I'm just going to go through this exploit one more time and start everything in. So send an exploit, then it handles the exploit and then disconnects. So pretty much is this simple. I think the main part of this exploit is this. So we define the variable, we put in the first part of the variable, and then we append this to exploits where we reference the return address, the nops, and then the payload here dot encoded is substituted for our shellcode. All right, so Metasploit, we're telling Metasploit to use a default shellcode rather than us generating one. Metasploit automatically, by using this payload dot encoded, will generate automatically a shellcode that we can use to exploit this target. So save this. All right. So now the next thing to do is to move this exploit into Metasploit. So I'm going to do locate Metasploit framework in order to locate where Metasploit is actually installed on this machine. So you can see we have user share doc Metasploit. So I'm going to go to this directory. So I'm going to change my directory to this list, and you can see we've got different here, but this is where we're going. So we're going to change to modules. So we're going to the modules directory, list directory, and this is an exploit. So we're going into cd into exploit directory, list, and so Windows. So change directory to Windows and list. And here it gives us different options. So based on the protocol, is it a backdoor browser FTP? We're actually exploiting a TCP. But here it means miscellaneous. So because this is a customized script, I'm just going to put it in the miscellaneous folder. So you've got misc and then list. And probably there are some, some files in here. So if I do pwd to get this directory, copy this directory, and then I'm going to copy MSF. So I could name this exploit MSF skeleton.ruby, and I'm going to name it. I'm just going to move into this directory / and I'm going to call it von app.python. Oh, sorry, .ruby. All right. So that's been copied with this new name. So going back here, do a list, and you can see we've got the exploit here. Right. So now I can start Metasploit Framework. So MSF DB run. It's going to start the database and then start the MSF console. So I'm going to go over to my Windows machine and start up the vulnerable application. So run as admin. Okay, go back in here. All right, so we got no errors. If there was an error in our script, probably Metasploit will have picked that up. So it appears everything is fine. And I'm going to search for the exploit. So I'll call this von app. Nothing comes up. Right, so search. That was quite strange because I've got von app.ruby there. So search.ruby. It's not there either. Right, so let's be sure we're in the right directory. So let's do a list again. And I haven't got in the Windows here. So let's go back a bit and see why. So FTP, HTTP, miscellaneous, SMB, SQL. CDSMB, let's have a look, list. So I can't actually see any Ruby files here. So I'm wondering probably we're in the wrong folder for Metasploit Framework. So I think this is more of the documentation because the MD file. So probably we're in the wrong directory. So I'm going to walk my way back. List. CD USR. List. CD share. List. And probably we're in the wrong folder for Metasploit Framework. So let's do that again. So locate Metasploit Framework. So I don't think I've actually put in the right directory where the exploit needs to be. So let's have a look at this share Metasploit 1 rather than the documentation. So clear there and CD, because anytime you think when you update Metasploit, things get changed and there's no documentation for it in most cases. So I go in here, list. Do I find anything with modules? Yeah, CD modules. List that as well. And probably this is the right directory we need to be in. So CD exploits, list, and CD Windows, list. Yes, so this appears to be much more better because probably I should have TCP. Do I have TCP anywhere here? I don't have. Do I have a miscellaneous? Yes, I do. So this was the directory I was looking for initially. Yes, and you can see all the files here are Ruby files. So this is where our exploits needs to go. So I do a pwd and to see this directory, open up a new window and cd into where I've got my exploits. So cd exploit list, and then copy copy that to here. And I'll call that Von app.ruby. So that's been moved. So now I think you could do reload. And probably that should update the exploits. If you take a look, we've got, yeah, so it's not reload. MSF reload, I think. If not, I'll just exit from this and restart MSF console. I think it's reload or update or something like that. So it's still saying it's not found. So just exit this and run that MSF DB again. So it's saying database, the following modules were loading with warnings. So it's saying there's a warning here and it's giving me, it says, please change the modules class from Metasploit 3 to Metasploit module. So you can see there's an error there. So I'm probably going to go into our initial directory, which is this. So list that and nano von. So let me just clear screen and open up the exploit. So nano von app.ruby. So, and then it says, would you change this to Metasploit module? Save that. Go back to Metasploit, exit, and rerun the Metasploit database. So hopefully this should go away and we shouldn't have any problems. Okay, so you can see the error has gone away, so we fixed the problem. So now I can search for the exploit. So von app. You can see it's giving us the exploit directory. So we can use exploit, and you can see the description as well as the disclosure date. So options now, and you can see our port has been set automatically. Our host we have to create ourselves, and you can see Windows Universal is the target. So I'm just going to set our host to the IP address of my Windows 7 lab machine. So I've got 87.140 options again, and hopefully the exploit should work. So just click on exploit and see what happens. Send it, and then we go. We have a Metasploit shell. So the exploit worked. If we type in shell, we're dropped into the exploit. So you can see by default, Metasploit use the Metasploit because we, remember we use the payload.encoded, and Metasploit would just use a default payload shellcode into our exploit. So if I do an IP config, the exploit, we actually successful. So I hope that explains how to move an exploit into Metasploit. Having a look at the exploit again, it's more about editing the template and knowing exactly where to go. I think all of this is quite straightforward. I think where you could have challenges when you're trying to convert a Python script is where you actually define the exploit from here, and what you have to put into these parameters. So this is what you use to define the return address, and the pack.v here is a sort of a gadget which Metasploit would then be able to convert that address. So if you remember, if we go back here, this is written 65, but remember in our exploit is actually written backwards, so 625011AF. So this allows the Ruby script to write this in Little Indian form. So we reference the target return address, and this allows it to write it in the Little Indian. So it writes it backwards. Make knobs is used to create the number of knobs. So if you want 20 knobs, you can change this value, and then asking Metasploit to generate a customized or payload which is encoded. Send the exploit, and then we get this. So we should have got this message, send exploit. Not quite sure. Yeah, I got it here. So send an exploit. That was the message that was that we printed out, and then successful connection, and we got a Metasploit shell. So thanks for watching, guys, and see you next time.